This is the Earth Science Classroom. We're in the Rock Cycle Part 3 video, which is in the Rocks playlist. I'm looking at the igneous rocks turn into sediment as this part of the rock cycle. So as you can see by the diagram given, I have magma and lava down here, and I have igneous rock here. So the first video was on this kind of like process from what magma is to the formation of igneous rocks. And then this video, we're going to look at, obviously, igneous rock and look at the formation and processes included in creating sediments and how this plays a large role in the larger cycle and moving material between the three main rock types, which is igneous, sedimentary, and metamorphic, and how it goes from a solid igneous rock, which means from fire, derived from magma or lava, into sediment. So let's look at igneous rock. And igneous rock obviously is derived from magma or lava, and lava being the extrusive or volcanic in nature. And we have magma, which forms underground, and it is intrusive, and it is plutonic in its environment and formation. And the lava is going to create or cool down a lot quicker. It's going to crystallize and consolidate a lot faster than the magma that's intrusive, thus creating different kinds of igneous rocks, from intrusive rocks to extrusive. This goes as far as discussing different characteristics, the chemical and physical makeup and appearance and characteristics of those different types of igneous rocks. And I'm going to use granite as my classic intrusive. I'm going to use basalt as my classic extrusive igneous rock for the rock cycle. So let's say you form either granite or basalt. And let's just take granite, for example, okay? And granite is intrusive, so it's formed inside the earth deeper down with heat and pressure, and it's a slow cooling process. It crystallizes slowly, and it contains more of a myriad of different minerals of larger crystal size and growth because of the time it takes to cool down inside the earth. The geothermal gradient is low or slower, and therefore creates a more diverse rock. But because it is underground, it is formed inside the crust or lithosphere, or even the upper mantle. You need to have a process called uplift, which obviously by the term is a process of taking a piece or layer or region of rock and moving it towards the surface, so decreasing in depth. And as it goes towards the surface, you're going to have a different environment. It's going to be colder, less pressure, and it'll eventually be pushed onto the surface of the crust. Now, that could be the surface of an ocean floor, or it could be the surface of a continental landmass. But either way, it's on the surface. Now, this uplift is a consequence or a byproduct of tectonics. Whether it's upwelling, whether it's continental movement through plate tectonics, you have a regional uplift of areas. This is also called orogeny as well. So orogeny is the process of forming mountains. By the same process, you are pushing rock together, and rock is pushed up towards the crust or even higher in elevation into the atmosphere, such as mountains are. So you have this uplift. So you're pushing the granite up from where it was originally formed, deep in the ground, and it basically now is part of the surface topography, the surface geomorphology, as an outcrop of bedrock. It's exposed to the elements. And when I say elements, I mean the weather, the climate, the wind, the action of water, action of chemical solutions on the rock, and you would obviously get the process of weathering. acting upon that exposed rock on the surface of the crust. And we know weathering can come in two main divisions. We have the physical or mechanical weathering, and also we have the chemical weathering. So the weathering aspect of the rock is I've done in more detail in different videos, so please check it out. Also, same with magma and lava, but just to describe it here and how it fits into the big process. So once you have that rock on the surface, on the crust, it's exposed to the elements, and you get, over a course of time, some faster than others, you get the process of weathering, and weathering is the breaking down of the rock into smaller and smaller pieces. And you can also discuss the effect of surface area on the speed of weathering. Obviously, the greater surface area, the more area of the rock is exposed to weathering, therefore the faster or increased rate of weathering occurs in that particular location. And that can differ around the world. Some locations have fast weathering because of the environment, and some are slower. Okay, so that was just for rock that was intrusive. So in terms of the granite or any kind of granitic kind of rock, the intrusive rock. In terms of the extrusive rock, and my example is basalt, which is the majority of the ocean floor, and it composes some of the continental landmass as well. Basalt, which is volcanic in nature and environment, so you have some sort of crack or opening in the Earth's crust, therefore a volcano exists, and the classic volcano can have different types and different variations, but it's essentially a crack in the crust, allowing the magma to rise up through decompression, melting, and upwelling and pressure to allow lava to flow on the surface, either creating LIPs, which is large igneous provinces, or just obviously volcanic activity, which we have in the Ring of Fire and various areas around the world where you have the continuing tectonics and subduction at work to create the volcanic activity. Again, all these are discussed in different videos. So you have this basalt. Now, once obviously it erupts, it is now going to be part of the surface of the Earth and create new rock and new crust, as you do with volcanoes and with the mid-ocean ridges in the ocean. There we are, so new crust. And once it's there, you do get the exposure to the elements. So we're back to the area or the rock being under the weathering kind of conditions over the course of time. Now, so it's the same outcome. It's on the surface, it's going to weather. And weathering is, again, breaking down the rock. Okay, so you add weathering and you start to get the breaks in the rock. And then what happens is you get smaller pieces of rock, and it continues to get smaller and smaller and smaller, and these are called grains. So you get to a certain size or a certain level of weathering where the rock is now in different pieces of different sizes. This is called sorting and grain size. And once it's happens, we call this sediment. So sediment is created. It is the broken bits of rock as a product of weathering. It's the outcome. Now, the source rock in this case is igneous based on the arrow. The source rock is whatever rock is being broken down to create the sediment. So if it's just purely granite, then you'd have sediment, which is granite in nature, and you'd have the 5 main minerals in granite, and you'd have obviously different colors and different textures of minerals within the sediment created by the granite. But you can also have a mixture of rocks and multiple source rocks, or also called parent rocks, to create the sediment. So the sediment are these little bits, and they can be well sorted, or they can be randomly arranged in size and shape characteristics, but the grain size is important, and the level of sorting. And obviously, if you sustain, have more consistent weathering, you're going to have a more consistent grain size and consistent characterization of those sediment pieces. So we discussed the granite and the basalt, and how they can be broken down through weathering to create sediment. So the sediment are the little bits of rock that are created through the chemical or physical mechanical weathering that takes place on the Earth's crust or in the very top layer of the crust, exposed to the elements over a certain amount of time. So once we have the sediment, then we're going to go into the process of creating sedimentary rock. Now there's a step-by-step process of which this occurs. And I'm going to do another video. This is part 4. So part 4 will look at in detail the process of taking sediment and creating sedimentary rock, the process of lithification. So thank you for watching. Check out part 2 and part 4, and hope you learnt or as valuable information for the rock cycle in a bit more detail.